Okay, Wildcats. Today we're looking at Monday, September 17th, graphing absolute value functions, and that's going to be on page 11. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, graphing absolute value functions on page 11. Absolute value information. It's the distance from zero. It makes values positive. F of x equals the absolute value of x is a parent function. Domain is negative infinity to positive infinity. Range is bracket 0 to infinity. All right, absolute value transformations. F of x equals absolute value of x is a parent function. Now, you've seen this before, but we're going to apply it to absolute value. Where we had parentheses, we now have the absolute value. Okay? The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. If it's plus h, it translates left. If it's minus h, it translates right. If it's plus k, it translates up. If it's minus k, it translates down. If you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, and again, don't forget this is going to be on page 11. All right, graph the absolute value and state the transformation equation and the domain and range. So here, let's start looking at the points to graph wx equals absolute value of x. So if x is negative 3, excuse me, then the absolute value of negative 3 is positive 3. If x is negative 2, the absolute value of negative 2 is positive 2. The absolute value of negative 1 is positive 1, and so on. All right, so let's graph that. So negative 3, positive 3. So 1, 2, 3, 1, 2, 3. Negative 2, 2, 1, 1, 0, 0. 1, 1, 2, 2, 3, 3. All right, domain and range is from negative infinity to positive infinity. The range started at 0, goes to infinity, so bracket 0 to infinity. All right, let's take a look at example 2. All right, now the parent function points are also the directions of the graph because these directions will always make that V shape for absolute value. Okay, so the first thing first, you take the vertex, which we know is 0, 0 from the parent function. This tells us the transformation is up 3 units. Okay, so 1, 2, 3. From there, we know that these points we can use as directions, not points, but directions. So negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So from this point, we go left 1, 2, 3, up 1, 2, 3. From this point, we go left 2, up 2. From here, we go, and that's not 0, 0, sorry. This is our HK, our vertex. See, these aren't points. These are actually the directions. Here, they're points because this is the parent function, but here, we're using them as a direction. So left 1, up 1. Right 1, up 1. Right 2, up 2. Right 3, up 3. Okay, and the key here to understand is in a transformation, once you move the vertex, you can use the directions to give you the shape of the function. All right, domain. Domain of absolute values, always negative infinity to positive infinity. Range is, it was at 0, but now it went up 3, so it's bracket 3 to infinity. Okay, let's move on to example 3. All right, example 3. All right, so here the minus 3 means the vertex actually moves right 3. Okay, so we were here, and we're going to go 1, 2, 3, because that's the minus h. And from our notes, we know that minus h translates right. All right, so now we can graph by direction. So, and really we use -3, but you could also just use -2, 2, -1, 1. HK we moved. 2, 2, 1. Oh, I'm sorry, out of order there. 1. It's not wrong, but it just looks weird. 1, 1, 2, 2. So from the new vertex, we move left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. And really, you could have your directions all the way up to 10, 10, 11, 11, but that's enough to give you the shape. All right, so as we said, our transformation was right 3 units. Domain is negative infinity to positive infinity. And range is bracket 0 to infinity. All right, example 4. All right. And let me put that direction way too high up here. Didn't realize I took away space for the range. Let me change that here. And I'm going to draw a line to give space for range so I don't accidentally draw in there. All right, so first things first, we know our vertex was at 0, 0. This tells us we move left 3, so 1, 2, 3, and then that tells us we move down 3, so left 1, 2, 3, and then down 1, 2, 3. All right, so now we graph by direction. So we know -2, 2, -1, 1, H, K, 1, 1, 2, 2. And before we do that, don't forget about transformation. So we went left 3 units, down 3 units, all right, so, but we can't forget about the negative. That negative means we're multiplying the y direction by -1. So 2 times -1 is -2. 1 times -1 is -1. 1 times -1 is -1. 2 times -1 is -2. So now our new directions are left 2, down 2, left 1, down 1, right 1, down 1, right 2, down 2. So we go left 2, down 2, left 1, down 1, right 1, down 1, right 2, down 2. All right, so you can see that the last transformation was that it reflected the x-axis. All right, so our domain is negative infinity to positive infinity. Because it reflected the x-axis, the range changed slightly, so now it's negative infinity to, it looks like, -3 bracket. All right, last example. And I'm going to change the 1/4 to a 1/2, just because I think it will make the problem a little bit better. All right. So we move the vertex right 3, so 1, 2, 3. So that's one of the transformations, right 3 units. Now we're going to graph by direction. All right, so we know our directions are -2 to -1, 1, HK. That's our vertex. That's our new vertex. 1, 1, 2, 2. Okay. So here, just like in example 4, where we had to multiply by -1, now we have to multiply all the y directions by 1/2. Or you can just divide by 2. So 2 divided by 2 is 1. 1 divided by 2 is 1/2. 1/2, and 1. So from here we go left 2 up 1, left 1 up a half, right 1 up a half, right 2 up 2. All right. Now, from our notes, we see here that A is greater than 0 but less than 1, so it's a vertical compression. So the transformation is a vertical compression of 1/2. All right. So with that, if you understood all the examples, start working on the assignment. If you didn't, just know that you have options in class where you could work with a partner in small group, or you could work with me in the teacher-led station. Okay. So with that, have a wonderful Wildcat